My organic synthesis journal is on catalytic diazoalkane carbonyl homologation, synthesis of diphenylcycloheptanone and other quaternary or tertiary aryl alkanones, and spiral cycles by ring expansion. There aren't caution notes, but there are possible hazards associated with the chemicals involved in the procedure. A risk assessment of potential hazard should be carried out before the experiment on the scale that is planned for the procedure. The experiment is relatively inexpensive except the reagent scandium-3 triflate, since it costs about $65 per gram, which was purchased from Sigma Aldrich. The setup for drying scandium has a 3-necked round-bottom flask equipped with Teflon-coated magnetic stir bar. One side neck and central neck are fitted with glass stoppers. The other side of the neck is fitted with a short path distillation head. It is connected to an argon inlet. Its branch is fitted with a round bottom flask, which creates an argon atmosphere. This is maintained throughout the reaction under continuous argon flow, and it creates a stable environment. The second figure shows the reaction setup, which has a 3-neck round bottom flask again, and this side has a rubber septum, and the other neck has an argon inlet and outlet. The central neck has a pressure equalizing additional funnel. The reactant is diphenyl diazomethane, which was prepared by applying Jade and Brewer's method. The reagent, scandium-3 triflate, was purchased from Sigma Aldrich, and so was the other reagent, cyclohexanone. The solvent toluene was purchased from Fujifilm Waco Pure Chemical Corporation, and the desired product for this experiment is diphenylcycloheptanone. The first step is to dry the scandium by using a distillation head connected to an argon inlet and vacuum. Then the apparatus is evacuated to 0.3 through the vacuum line. The flask is immersed into a preheated silicone bath. The catalyst powder is stirred for 12 hours. The white phosphorus pentoxide powder turns to a white, sticky, white-pink solid containing phosphoric acid residues, as seen in picture E. The flask is removed from the oil bath, then cooled and backfilled with argon. A pressure equalizing addition funnel is attached to the central neck, and the side neck has a argon inlet and outlet attachment. The flask is evacuated through the vacuum line and is backfilled with argon. This is repeated 3 times. The flask is positioned over a magnetic stir plate in a fume hood. Then toluene is added to the flask by using a syringe through the rubber septum. After that, 4.2 milliliters of cyclohexanone is added by a syringe through the rubber septum. Immediately it turns from a white to a pale yellow homogeneous solution. In a separate flask, 7 grams of diphenyldiazomethane is dissolved in heptane. Then it's added to a pressure equalizing funnel. The solution in the additional funnel is continuously cooled to 0 Celsius and shielded from light by using aluminum foil. Is added dropwise to the reaction mixture over 3 hours at 24 Celsius. The solution is stirred for 3 hours. The reaction mixture is light yellow but contains brown oily precipitate comprised of scandium-3 salts. The heterogeneous mixture is diluted with diethyl ether. The result reaction mixture is transferred to a separation funnel. The pale brown organic layer is separated and the aqueous layer is extracted with diethyl ether. The organic layers are combined in a flask and dried over scandium sulfate for the 10 minutes. The drying agent is filtered through a plastic funnel with a cotton plug into a flask and rinsed with diethyl ether. The filtrate is connected by rotary evaporation and dried on a high vacuum for 10 minutes. It furnished 10.8 grams of pale brown translucent oil that contains crude homologation product. The crude oil is purified by flash column chromatography on silica gel using hexane and diethyl ether and elutants to provide 5.34 grams of desired product as a pale yellow solid. Then a TLC of the reaction mixture is analyzed. The reaction workup is involved in an extraction that was seen in the slide previously. The drying agent was filtered through a plastic funnel and rinsed with diethyl ether. The filtrate was concentrated by rotary evaporation and dried on a high vacuum. This furnished 10.8 grams of a pale brown translucent oil that contains the crude homologation product. The product was purified by using flash column chromatography on silica gel using hexane and diethyl ether as elutants. C-SAN is added to the top and bottom of the column. The crude oil is loaded onto the column using 10 milliliters of toluene. Then fractions are collected. The product's appearance is pale yellow solid, and its purity is determined by QNMR by using trimethoxybenzene. There was 55% purity determined. The first NMR displays how the purity was determined, and this is the second NMR. There weren't any safety notes, but a risk assessment should be carried out with regard to each chemical substance and experimental operation on the scale planned. There are some websites listed in order to help with that risk assessment. And this shows the overall reaction. So first we have a resonance form, and then there's a nucleophilic attack. It shows a C double bond O activated. Then we have a loss of the N2 gas, and here's an epoxide formation, and there's intermediate angle strain. So the epoxide has to break open, and then we have a 1-2 rearrangement, and then H2O is added and the scandium goes off. I believe we are able to do this in our lab because we have the same equipment used in the experiment. And these are a list of the references. And this slide about two of the authors, Jason Kingsbury and Victor Rendina. And this slide shows the other two authors, which are Jacob Berman and Brittany Smolsark. And this slide shows a little about the people who checked the journal, which are Junjichi Tagachi and Haruka Fujino. And that is my presentation.